So members, we have used the binary coded decimal code system, which we have found to be at least a little bit more faster, especially when we find that we are converting big or large figures that if using the division method would be tedious and can even result into a number of errors. So we are going to use that method to solve this number, which they are saying the IP address of a computer is given as in the table below. They are saying the computer then converts it into binary numbers. So they are saying show the conversion of the computer. So maybe let me pick this table and paste it here so that we get to do this number. So we are going to first understand the IP address. First of all, has got 4 octets.
What was the question?
They are saying the IP address of a computer is given as below 192.168.16.100. Then they are saying the computer then converts it into binary numbers. So they are telling us to show the conversion of the computer, meaning they want us to convert this IP address to binary number system. So maybe before I talk about the 4 octets, you can, I don't know whether you can also help us understand what an IP address means and why is it important in computer networks. Mr. Brezius.
Oh, okay. IP itself in full is called Internet Protocol.
Yes, sir.
So, a protocol in computer systems is like a set of rules that is governing the way how data is transmitted during communication. Now, when they say IP address, it means that is the location of a certain data over the internet. So when they say an IP address of something, it means a certain gadget is being located using a certain location over that internet. Okay, because the internet is like the network of all networks.
Yeah.
So that's the idea. So when they say we have 2 gadgets, for example, for them to communicate, it means one gadget is located in a certain area and another one in also a different area.
Yes.
So both of those 2 nodes in network, they call them maybe nodes, they will be having different IP addresses. For example, if computer A has an IP address of maybe 192.168.100.1, then the other can be 192.168.100.2. Means they are in the same we call them classes, but they're on the same network but different IP addresses.
Oh.
Yeah, that's just the simple overview.
Okay. Thank you so much for that information, and I believe it has sunk in our minds.
I don't know whether Sarah's got the idea.
I don't know whether, maybe. Sarah, are you on?
Yes, I'm trying.
Okay. So basically, for me, how I have understood from him is saying an IP address helps different devices to communicate or exchange data. In other words, the protocol itself is like a set of rules. So if it becomes an internet protocol, it means it's a set of rules that governs now the exchange of data or information over a network. And the network that we are specifically talking about is internet. That's why he's talking about of nodes where you have one computer and another computer at the other node exchanging information, but which information is passing through or is being obtained from the internet. So what
Yeah,
makes
actually,
those? Yes, engineer.
yeah, actually, just have an example of where you guys are staying. Maybe you stay in house A,
Mm.
and you know you are staying in Bukoto, and then the other one is also staying in Muyenga.
Mm.
You have your maybe, can I say, PO box number.
Yes, sir.
Maybe your box number is 200 and my box number is 300. These box numbers help the other users identify our different locations. So over the internet, these are nodes, devices, or any things that consume resources would be identified in that way by using IP addresses.
Oh.
Yeah.
Okay, so I can say it is analogous to our box numbers. So that one is able to know I'm going to send this information to location so and so in a way that even the other one is able to know the other one's location, and so they are able to seamlessly exchange information. Thank you so much. And for this one is for devices, and your devices always communicate over the internet using this kind of unique address. I think there are also other addresses like MAC address, of which I have seen that for it to work within the local network, whereas the IP address works outside your local network. In other words, you have a network here, maybe using your MiFi that is giving you an access to internet. So you find,
Yeah, exactly. MAC addresses work under the physical layer.
oh,
So that is the address on the machine itself. It is more of like the real identifier of the machine before it goes even to the internet.
oh, okay. So thank you so much. And why do we call these digits octets? I think they are made of 8 binary digits, isn't it?
Exactly.
Okay. So they are
Just like you
octets.
hear the word octet, it comes from octo, 8.
Oh, okay. Because they are in groups of 8 binary digits. So that means I'm going to have 192.168.16.100. And it is like you said, it is 192.168 dot we said this is
You could
a
say 100.
16.
Oh,
It is 16 then 100. Ah, so that's why you see now the binary conversion system becomes very important, because this IP address is actually, when you go to compute like networking systems, you really see that it happens with a lot of actually, there's a lot of technology involved, which is always hidden away from us. There is something called the domain name system, and they always say it's what converts what we see as the domain name, for example, google.com being a domain name, then the domain name system converts this google.com into, from the human readable form, into an IP address that can then later on be used for the computers or for devices communicating over the internet to exchange data or information with each other. So there is always a lot of things that actually we don't see with our eyes, but when we don't go deep to understand them, we always look like, you know, the things are just like obvious, and yet they are not so much obvious. So this IP address thing is really very important if we understand it. So now I want to look at the 192.168, 106, then 100. So we want to convert each to 8 digits. Each we must convert it to 8 digits. So we are going to begin with 92. 192, we go to that, we go to that, we go to that. So if I want to do that, I'm going to draw my table with if I'm talking about 80 digits, that means I will stop at the 128. That is 2 to the power 8 minus 1, and this becomes 2 to the power 7. This is 128. So I'll start from 1. I go to 2, 3, 4, 8, 16, 32, 64, and 128. So when I look at the 192, if I get 192 minus 128, I'll have 64. So meaning I can use 8 digits to write or to represent 192. By going to 128 as my first digit, I write 1 because I have found out that if I get 192 minus 128, I'll remain with 64, which I can get from the remaining numbers. So that means if the remaining one is 64, I got 64 and put 1. If I get 128 plus 64, I get 192, meaning I have finished my 192. The rest will be zeros. 0, 0, 0, 0, 0. I got 168. This is 192. I got 168. So 168 also is above 128. So meaning 128 can be inclusive. So I will write my 1. So what about if I get 128 minus okay, I get my 168 minus 128, I would get a 40. So if I go to 64, I see it cannot qualify because it will go beyond this. So I put a 0 to 64. I move. So I said I'm remaining with the 40 to become 168 if I added it on 128. So I got 32. I find 32 is less than what is remaining. So meaning 32 qualifies to be part of these numbers. So I'll put a 1. So if I put a 1, I'll be remaining with 8. So 16 is not inclusive. Then 16 is not inclusive, but 8 is inclusive. So if I get 32 plus 8, I will get 40, plus 128, I will get 168. So meaning the rest are zeros. Now I got 16. If I got 16, I automatically find that 128 does not qualify, 64 does not qualify, 32 does not qualify, but 16 qualifies, and the rest are zeros. What about 100? So 100, if I go to this, I'll find 100 is less than 128. So 128 cannot be used to express 100, so I will say that is 0. But when I go to 64, I find it is less than 100, meaning I can get 64, and the end of the remaining figures, I can pick them, add them to 64 and get 100. So meaning 64 can be inclusive. If I add there 32, it will become 96, meaning 32 is also inclusive. But if I add there 16, it would go beyond 100. So 16 is not inclusive. And this is 96. If I added there 8, it will also be beyond 100. But if I added there 4, it will be 100. So a 4 is inclusive and the rest are zeros. So, okay. So I'm trying to increase to get space. Okay. So what does this tell us? It tells us if I'm now to write my IP address of 192, 168, 10, and 100. I'll just write them the way they are. I'll have 1, 1, 0, 0, 0, 0. How many zeros?